Good afternoon. Thank you very much for joining my session. I hope you'll find it interesting. I'm Lois Gray. I'm an academic lead developer for the University of the Highlands and Islands. And I'm also a part-time engineering lecturer at North Highland College, which is one of UHI's, that's the acronym for the University of the Highlands and Islands. They're one of the academic partners. So back in 2019, I was actually working in industry with a company called Denshi Power, who manufactured high volume, high reliability lithium-ion batteries, mostly for the defense market. And I was working in quite an automotive production line environment. I was responsible for the test equipment there. So I was responsible for things like robots, cobots, automatic test equipment, and Internet of Things connected test equipment. And at the time, we were trying to recruit new graduates to design equipment for this automated environment designed for manufacture. And I found we had a lot of trouble recruiting people. So we had quite a lot of applicants, but they tended not to have the right skill sets, not the right technical skill sets, and not necessarily the correct graduate attributes required for this sort of quite collaborative environment. And the other problem that we also had was that we attracted a very poor diversity of graduates as well. In particular, so I didn't expect there to be huge numbers of ethnic minorities because the factory is located on the north coast of Scotland, and not many people want to live in such a cold climate. But I was disappointed that there were very few female engineers applied as well. And actually that's been a bit of a bugbear of mine for quite a few years. So I'm a member of the Women's Engineering Society, Women in Engineering, which is an American society as well. And I'm also a member of a special interests group, which is particularly focused on increasing inclusion, diversity, and I can't remember the ethnicity in engineering. So in 2019...
Sorry to interrupt, Lois,
put my slides up. I'm going to do that just now.
All right.
Is that what you were going to ask?
Yeah, just wanted to check.
I'll do that just now.
Okay.
So hopefully you can see the slides now.
Yep, lovely. Thank you.
That's fine. So as I say, in 2019, a job came up with the university, and I had been teaching before I went back to industry. And the job was to develop a new engineering curriculum. And I felt this might be quite a good opportunity to develop something quite different that would improve graduate employability skills in engineering, particularly going into this Industry 4, which is hailed as the fourth industrial revolution, where robots will probably take the place of many traditional engineering jobs, and the engineering workforce will need to become far more collaborative, able to work in teams, internationally connected, supportive, that also coincided with what I see as quite feminine attributes as well with engineers. So the sort of supportive, empathetic type of people are quite often females. So I felt that the new graduate program could attract not only more gender diversity, but it could also prepare students more for this Industry 4 environment. So I did some research, background research into what employers in our region were particularly looking for. And I found that soft skills were particularly in demand. Skills Development Scotland, for instance, had just produced a new document where they'd really emphasized what they call meta skills. We probably know better as graduate skills. And also the IEEE at this time, who I'm a member of, they were pushing very hard for a new thing called Engineering Education 2.0, which again was very focused on sort of project-based engineering. So quite different from traditional engineering courses. Rather than having exams, they would be, everything would be project-based, coursework-based. In fact, there were some universities in Australia that were built brand new without classrooms at all, just with big sort of project rooms. So some equipment for the students to work on, but mostly just sofas and places where they could have chats and discuss ideas, exchange ideas. and the assessment would be entirely based on that. And I thought this might be quite a good thing for our university to get involved with in this new curriculum as well. So if I go down. So this is a sort of summary of what I found from sort of secondary research of various government papers, published reports, the IEEE information, and various other things. So there seemed to be much more emphasis on soft skills than on technical skills, and a lot of emphasis on project-based learning, which is one of the things I think is really good for students anyway. So I followed UHI's curriculum development plan, which you can see here. We actually haven't got very far in this. We've only got as far as the business case. But anyway, I had the original idea. I checked it was supported by research, brainstormed with the faculty, and then we got to this employer-supported question mark box, decision box here. And at that time, we went into lockdown. So my idea had been to run focus groups with regional employers, actually probably visiting them, getting them to come together, presenting ideas to them. And of course, we couldn't do any of that because COVID prevented travel. So we decided, myself and the Curriculum Development Employment Engagement Officer, UHI really like long titles, decided to carry on with the focus groups, but to do it in a completely online environment. And we took a two-part approach. So the first thing we were going to do was showcase some of the work we'd already been doing in this area in the university. So there was a new applied software development program, which had just started. That was running down at Murray College. And what was really new about that, it was a completely project-based approach, but not only project-based, also agile. And there were students from levels, I'm not sure what the English levels are, but SEQF level 7 up to SEQF level 10, which is honours level, all collaborating together, all working on real world projects. And a big manufacturer, IBM, were on board with this right from the very beginning. So there was really good employability built in as well. And IBM actually provided all the software from them, did quite a lot of the promotion of the course as well. And the students are doing really well on this. They won an international competition last year on energy sustainability. And they also won another competition about disaster resilience by writing code in these large project groups containing all levels of students. So I thought this was quite a good showcase for an engineering program that was project-based as well. So we're going to present this case study, but we had to do it online, which was okay. That actually worked out quite well. We had really good engagement because it was online. I think employers were keen to come to the sessions because they didn't have to travel, they didn't have to take a huge amount of time out of their work. So actually the online environment quite suited the focus group method. And we progressively presented developments in the program to them, starting from the very first time, just asking them, what do you want? What are your skill shortages? What do you see as being your skill shortages in the future? And it was very much a discussion and interactive group. So we ran 3 of these. The third one where we actually presented a program structure, and they were all very much on board with that. They particularly liked the idea of work-based study, whereby the students could do tasks in their workplace, not even necessarily tasks provided by the university, but possibly just workplace tasks, and they could gain academic credit for that. That suited them very well because it meant they didn't have to, it wasn't disruptive to their main work and what the students were doing there. But obviously not everybody could attend the synchronous sessions, so we also opened up a Sharepoint site, which was completely open, so employers could post to this their ideas, questions, discussions. There was an open part where they could discuss with each other, and there was also a closed part. So if there was IP protected information they wanted to share, they could do that in the closed bit and only ourselves would see that. And again, that ran quite well. We got a lot of good ideas from the employers through that, and which supported the synchronous sessions. In fact, everybody seemed to be on the same idea as to what they wanted with a new program. So these are the sort of summary of what we found out. Not really surprising, pretty much what we expected and what we'd found from the research. Employers were keen that students could work on real-time practices and procedures, real-life problems. They were keen for students to be able to easily intertwine their university and their work learning, because of course, even though it's a project-based course, there will still be some taught elements. The more technical subjects still need to be taught. So they wanted a way where the students could possibly do some of their taught element work while they were in the workplace. They wanted flexibility, so they didn't want to have employees signing up to a 4-year undergraduate course, and that being it. You know, they had to do the 4 years, they had to attend classes, blah, blah, blah. They wanted them to be able to go in, do a module, stop, do another module, another term maybe, or leave, have a little gap, so it would suit their work practice better. They also, so one of the ideas was that we would have mentors. So because it would be work-based assessments, the students would need mentors both in their workplace and in the university. So that was our initial idea. And then some of the employers, some of the small to medium enterprises said, oh, we would just prefer university mentors. So we decided, yes, we'll make the course flexible enough to just have a university mentor if that's what they prefer. And then we also looked at an external mentor, so for from an accrediting body for the employees or students who wanted to become registered engineers. And then, of course, recognition of prior learning was quite important, because a lot of the people who might be interested in this course are probably not going to have 5 A's from school. They're probably going to be more mature learners who've maybe been at work for a wee while. So recognizing that their work is valuable and can count towards the course was quite important as well. Oh, right. Okay, so that was the part about sort of the aim behind the program. But one other thing I felt was very important was to instill digital skills into the students. So you've probably heard quite a lot about digital skills. It's been in the news quite a lot. And one of the best ways I feel to do that is to incorporate the digital skills seamlessly within the course, so that we are using digital technologies. Students get exposure to them without any of the risks. And they just immerse themselves in the digital technologies without even necessarily even realizing that they're doing that. So I'm guessing some of this is quite old hat, and most of you may have used some of these things before, but it's quite unusual for UHI to combine them all into a single program and a single package like what we're planning to do. So weekly discussion boards, I've used them in my classes for many years, sometimes without a huge amount of success. But what I've been doing recently is making them problem-based. So I'll set the students a problem and I'll say, I'm not going to help you with this. You go away, you talk to each other through your discussion boards and you solve the problem for me. And that's worked quite well. The students have been quite engaged with that. Another thing that's particularly important for problem-based and project-based learning is that the students keep a record of what they're doing, and that they also reflect regularly on how they're progressing, what they're learning, how well it's going for them, how badly it's going for them. So one of the main assessment methods for this new program will be the students' e-portfolio, whereby they'll put all their summative assessment information and also formative assessment as well, reflections, team reflections, any external learning they do. And the idea is that they'll build this portfolio over the course of their career. So they'll take it with them when they finish university, and they'll carry on adding their continuous professional development into this portfolio. It will form a place where all their learning is gathered together. Another thing, which I guess probably most of you have done quite a lot with, is breakout rooms. So all my teaching has been online over the last 2 years. And in fact, it was online before that for quite a wee while as well. But so what I found with breakout rooms is that students can be quite reserved initially when they get put into a breakout room. But if you, again, set them a problem and say, you have to present on that problem when you come back into the main room, solve that problem, that does push them to talking to each other, and to, maybe it's just engineering students, of course, that are a bit reserved. Maybe other students are okay, but my experience of engineering students is they don't naturally speak to each other unless they're forced to. So this has worked quite well, and it's something I'm definitely going to build into the new program, is breakout room activities. And then another thing, which is a bit new for UHI, it's used a lot in American universities, is this Internet of Things enabled remote equipment. So we buy quite a lot of application software specifically for engineering. And just recently, these companies have come really on board with the online environment. They've put a lot of their applications into the cloud so that now students can access things like remote weather stations, racing cars, a whole range of different things through the internet, through these IoT enabled remote equipment. And I'm going to build that into the course because that gives students exposure to the sort of work I was doing when I was in industry, accessing remote equipment, data analysis of the results you get from that equipment. And all this is provided with the apps that we currently have. In addition to that, I'm also going to be supporting their lab work with this bespoke remote equipment. So this particular one's a pressure control rig, but we're going to be using a level control rig because that's more visual. And the idea is that there's a camera on the rig and the student can see the levels rise and fall while they're doing their experiment. They can experiment with different control theories. And it almost replaces laboratory work. Now, I would say it doesn't exactly do that because the students still see it a little bit as a simulation. They don't really appreciate that they're using real equipment. So we are still planning to have real labs as well, but these will be greatly reduced because the idea is that we want to be prepared for a fully online environment should that happen again and be able to switch over to that really quickly. And then one other thing which we've used in the past quite a lot is simulations. And again, these are good because they are what industry are expecting now. So industry would expect if you were doing an engineering design, you would simulate it until you'd proven all the concepts you could through simulation before going into actually using hardware and building a real thing, whether it be a car or a, I don't know, whatever it is, a nuclear power station. You would have done all the simulations. So we will use this in the course as well, but this isn't particularly new. We've been doing this for a long time. It's just that a lot of these things are now much more accessible through the cloud, so easy to build into a course. So the university's been quite progressive in that we have a tool which we call Forge. Unfortunately, it's just internal just now, but I think it's something that could be quite sellable myself. It allows lecturers to produce resources that look something like this here. Now, this isn't just a slide, it's an interactive website. It's a short, maybe not more than 4 hours of learning per object, I guess, so that the students can do them in little chunks and build up their knowledge that way. And it's got videos, questionnaires, self-assessment questions, links to other pages and all the rest. And they just look quite attractive, I think, and are quite nice for the students. And this is all done by lecturers who have no knowledge whatsoever of writing HTML type objects like this or of even the pedagogy behind them. It's just something that they can use. So that's one I produced. This is a 4-hour Excel one for first year undergraduates. That's another one that was produced by the university's education development unit because they actually produced the little video here, which I can't do. But all the rest of this can be done very easily with lecturers. And I think this is a great tool for the university.